Hi students, welcome to our physics class. Our chapter name is Electricity and Circuits. In the last class, we started this chapter and discussed about some of the things regarding the bulb, the cell and all. We studied that for one cell. Actually, this is not the representation of cell, this is just the diagram. You will study the representation of the cell, bulb, the wires and all in your 7th standard. Now you are just studying the outline. So we studied for the cell. It is having one positive charge and negative charge. That means we can say for the bulb, for the cell, it is having two terminals. Two terminals, positive and negative. So that we first discussed and we said that within the cell it contains some sort of chemicals are filled. When the chemicals are over, then this cell is not at all useful. We just want to replace that. So when we are adding more than one cell together, then I can call it as battery. So for one of this it is called what? Cell. And when I am connecting two or more, I can connect three. So when I am connecting more than one, then I can call it as battery. And that's the thing. And then we discussed about the bulb. For the bulb, it is having a glass structure. Then one metallic wire is there, and we are just connecting one line at this point and another at this point. This is the metallic cap, and so for the bulb also you can say that we have two terminals. This is the first terminal, this is the second terminal. Number is not important there. So we can understand that for the bulb also it have two terminals. Here also two terminals for the cell also. And another thing is this. Here we said that the wire present inside the bulb is called filament. Filament. We studied the definition for that. And these are the things we discussed in the last class. Now we are continuing these topics. So the things are very simple. Now I am going to draw some circuits. Here we have the cell. The bulb is here. Metallic cap is there. Our filament is there. And now I am going to connect this. I am connecting this with a wire on this terminal, positive, and I am just connecting this. Now what happens to this bulb? Do the bulb will glow or not? Generally, if our battery is okay, then our bulb is okay, then this bulb will glow. And if I am just taking a scissors and make a break here, now what happens? Do this circuit will, do this bulb will glow? No. Why? The reason is this. Here the electric circuit is not complete. The thing is this. Here you can see one gap is there. So I can say the electric circuit. What is this electric circuit? Here we have one cell and a bulb and they are connecting with wires. So I can call this as one electric circuit. This is one example for electric circuit. And so here we have one break and I can call it as the circuit is not complete. So our electricity is not possible to flow through this electric circuit. That means when I am connecting it back, now electric circuit, no gap is there, and I can say here the electricity is possible to flow. Electricity is possible to flow only when there is no gap in between these wires or the connections. And so, first you just want to study the definition for electric circuit. That means the question will come as what is electric circuit? For that, you want to study the definition of electric circuit. One thing. And here we said that when the circuit is complete, then the bulb will glow, or then the fan will rotate, or the mixer grinder will work. That means if the circuit is complete means if there is no gap is there within our wires or within our circuit, so I can say what? Then the device will work. The circuit is complete and so the device will work. The bulb will glow, or the mixer grinder will work, or the music player will play, like the things. So first we are going to study the definition for electric circuit. Electric circuit. So we already explained that. Now we are going to design it in proper beautiful statements. So it is an arrangement. It is an arrangement which contain electric supply, comma, wires and electric components which connected together and allow current to pass through. So this is the definition for our electric circuit. It is very simple. It is an arrangement. What arrangement? Which contain electric supply. What is this electric supply? Electric supply means source of electricity. Here within our circuit we use electric cell. That electric cell is one electric supply. When I am just taking the electricity from my main switch, that is also an electric supply. That depends upon the situations. So here we are only doing all the experiments with small cell or the batteries. So the thing is this, it is an arrangement. Within that arrangement, some of the things are included. Now the question is what are the things included, and that we are just listing here. It is an arrangement which contain electric supply. One thing. Next, how we can connect this electric supply and the electric components. What is this electric component? Electric component means bulb is one electric component. Fan is one electric component. Television is another electric component. That means the electronic devices that's working within the circuit. So we can say it is an arrangement which contain electric supply, our cell, wires and electric components which are connected together. That means all these components we are connected with the wires and there allow current to pass through. That means within the circuit the current can pass through. The simple thing is this, within our home we can see that all the wires are connected with the plug for the television and all. So that all is actually what? Electric circuit. That is a big electric circuit. Here I am not saying that that is only electric circuit, not like that. We can make small electric circuit only with a single cell, one bulb and some wires. That is also electric circuit. So it may be very big or small. The size will be depends. So this is the definition. Now the question is this. What is the direction of current We already said that for the battery or the cell, it is having a positive charge, here negative charge. This is one bulb, filament, and I am just connecting this with wires. And now the question is this: do our electricity is moving from positive to negative or negative to positive? That means, is it either positive to negative or negative to positive? What do you think? Is it positive to negative or negative to positive? What's the thing? Whatever the circuit, this is the thing, that our electricity will only flow, always it only flow from positive to negative. Positive to negative. That means our electricity will flow like this. First, our positive charges will flow on the wires, and then they are moving through our filament, and then back through the filament and finally to our wires. So, we can say the direction of current, it is always like that. Never you will get the direction in reverse, negative to positive. Never it's possible. So, always you just want to remember the direction of electricity is always positive to negative. It's flowing from positive to negative. That is the direction of electric current. That is very important. It will come as one word question and all. Or you just get the diagram and you want to mark the direction of the current. So you just want to mark it as arrows. And is it okay to give the arrows like this? No, never put like this. This is wrong. And the correct thing is this: our electricity is moving from positive to negative. That is the thing. I hope it's clear. And now, this direction, everything is okay. Suppose I am just connecting one cell and bulb. But this bulb is not at all glowing. That means it will not give out light. Why? What are the possibilities? One, within this cell, the chemicals may be over. If the chemicals are completed, what happens? Then this bulb do not glow. That is one possibility. Battery dead. That is, when the chemicals inside this battery is over, I can call it as battery is dead. It's over. And the next possibility, that is only one possibility. And still my battery is okay. New battery, the chemicals are perfect, but still my bulb is not glowing. Why? Then I just want to check the wires. Have any cut off or break with these wires? No, my wires are okay. That is also one possibility. Any break on wire. Any break on wire? That is another possibility that this bulb do not glow. Now I am going to the third possibility, that if any type of break or the filament may burn. Bulb fuse. That means, what is this bulb fuse means? It is very simple, that we know that inside the bulb we have filament. So this bulb fuse means the filament may get melt, or this filament may get burned out. That means when this filament gets burned out or melt, what happens? Then our wire gets open. There have some sort of gap will happen inside our bulb. So you can just observe from your home that some fused bulb. There you can see this filament is not there, or some sort of distortions will happen to this filament, and then what happens? Then the bulb do not glow. So the thing you just want to remember, why the circuit is do not glowing. One possibility, battery may dead. The second possibility, any break on the wire. And the third possibility, bulb may fuse. Fuse means the filament may get burnt or melt. That is the thing. Filament may get burnt or melt. Very simple thing. So that is the thing. And when I am just putting this cell continuously connected with wire, this bulb is always giving light. That means this will continue till my cell is getting dead. Is it okay? Do all our bulbs are continuously giving light? No. When we are sleeping, we just off the light. How we are offing this light? Using switch. Using electric switch. You know, you can see this switch. And now my question is this. How we can define this electric switch? What is electric switch? That is my question. How you can define that question? That now we are going to study. It is very simple. So our topic is electric switch. We are only discussing about simple switch circuit. That means within our home we can see different types of switch are there, and inside that the circuit and the structure is more complicated than this. We are only making this within your level. Very simple thing. And so again we are there on our cell and our metal cap, glass, filament, everything is there. And when I am connecting this with the wires, now this bulb will glow. And when I am making a break here, what happens? This bulb will off. When I am joining it back, what happens? It again will glow. Actually, the same thing is happening on our switch. So that means we are just making some sort of setup to make a break here. And by on the switch, what happens? This wire is again moving towards this point and then the circuit is getting closed. So that's how this bulb is getting on and off. That means when the break comes, now the bulb is off. When I am joining this again, then it is on. So here now we are going to make one electric switch. Very simple switch that you can make from your home itself. Very simple. For that we need 2 drawing pins. That means you can see some sort of pins are there on our notice board and all. A head is there and it is having a small pin. That is what? Drawing pin. So we need 2 drawing pins. We need 2 drawing pins. Then next I want a safety pin. Safety pin means what we are just putting on our saree and all. Or you can use another paper clip or paper clip. You can either use safety pin or paper clip. That is the other thing. First is you need 2 drawing pins, safety pin or the paper clip, and then the third thing we require is 2 wires, and the fourth thing we need a piece of thermocol or wood piece. If we have these all things, we can make one electric switch. Very simple electric switch. So first I am just taking the wooden piece or thermocol and placing these 2 drawing pins on that. That means I am just putting these 2 on the thermocol or the wood. Now I am just taking the pin. I am just attaching the safety pin on this. I am just attaching the safety pin. I am just attaching the safety pin on that. And the next is these two wires. The two wires I can connect at this one pin and the another pin. So this is the setup. Now my setup is okay. And the thing is this, actually here the pin is free to move. That means I can move this pin from one point to another. So when I need to open this, that means when I need to break the circuit, I just want to move this pin away from this point. I am calling this point, this pin as A. So when I am moving this pin away from this point A, then our circuit will be open. When I am moving this towards our pin A, then what happens? It will flow the current. Now I am going to do something, that I am going to add some sort of cell, bulb and all to this key. For this switch. We can call this switch another name, and that is what? Key, electric key. You will study in detail in your 7th standard. Now just study this electric switch. That's all. So here I am just putting our cell, then our bulb, and I am just connecting it to our switch. Now when I am moving this away from this point, our circuit is not complete, and so our electricity do not flow through this, and so I can call this as open circuit. And when I am closing this, that means when I am putting my pin, this is the representation of pin. So when I am moving this pin towards the nail or towards this pin, what pin? Drawing pin, what happens? Then this bulb will glow. And at that time, I can say that the switch is on. Switch is on state. Switch is on state when the electricity is flowing through the circuit. That means when I place this pin, safety pin near to this drawing pin, then what happens? The circuit is in on state. On state means then through the circuit electricity is flowing. So I can call the circuit is complete now. I already said that whenever the circuit is complete, there flow electricity, and so our bulb glow. Now the second possibility is this, when I am just open this, that means I am just placing this, what is this? Our safety pin. When I am placing this safety pin away from our drawing pin, what happens now? My circuit is open. This is open means no electricity will flow through this circuit, and so I can say my switch is in off state. Switch is in off state. So I can say for the switch it is having two states. One is on state and another is off state. On state means through that circuit electricity will flow and the bulb will glow. The second state is this off state. On this state what happens? The electricity do not flow while our circuit is open. That means it is having a break there. So the electricity is not possible to flow through this. That's all. So within this electric switch, first you just want to study the definition. Now I am going to explain the definition for this electric switch, and also you want to study how we can make one electric switch. Very simple. What are the things required? Two drawing pin, one safety pin or paper clip, two wires, one thermocol or wooden piece, and we just want to place this pin there, and we are just attaching the safety pin on one of the pin, and it is free to move through this, and when the safety pin touch on the drawing pin, what happens? Then the bulb will glow. If we are not touching the safety pin on this drawing pin, then the bulb do not glow. And the thing is this, when this is the safety pin near to our drawing pin, then it is on state, and when this pin is away from our drawing pin, that is off state. That's all. And the final thing today we are going to study is the definition for electric switch. Only the simple definition, and then we can conclude our today's class. And the thing is this, the electric switch. This is the definition for electric switch. Very simple. It is a simple device. We can call this electric switch what? It is a device. And that either break the circuit. Break the circuit means we can make open the circuit. We can break the circuit. That means actually we are just breaking the continuity of the circuit. So we can say that either break the circuit. At that time, what happens? Our bulb do not glow. This bulb is only one example. You can think about the fan, the television, the refrigerator, whatever it is. So either break the circuit or complete the circuit. When I on the switch, what happens? The circuit is complete. That means the circuit is closed. When the circuit is closed, the electricity will flow and our devices, bulb will glow. So as the definition for the electric switch, I can say it like that. It is a simple device that either break the circuit or complete the circuit. That means two possibilities are there. Either you can break the circuit or close the circuit. That means you can complete the circuit. This is the definition for electric switch. So just study this definition, very simple. And so this is all about today's class. Next day we will discuss about the conductors and insulators, that we can discuss in the next Wednesday. And so you just want to study this, and we will meet in the next class with the further topics in this chapter. Thank you.